Hi, I decided to actually redo my 4K PC build video, or at least add some commentary to the front of it that I released the other day, because there were just so many emails, YouTube comments, forum comments and whatnot, questions asking me why I chose all these various parts. And they're decent questions, because I didn't really explain that properly in the video, and it's probably just going to lead to more, like 6 months down the track, I'll still be getting emails and comments. Why did you choose this? Why didn't you choose this one? Why didn't you choose that one? And some people, quite a few people, have asked me to explain the thinking behind how I actually came to choose the parts in this 4K video. So I thought I'd redo it, add some commentary on there, and there are a few little things added to the throughout the video as well, just some little extra information compared to the previous one. But apart from that, the rest of the video is mostly the same. It's just me building a new 4K PC build video. So let's get into some commentary. Okay, first of all, what this video is not. It is not a how to build a 4K editing PC. It is not how to build the highest end 4K editing machine. It is also not a video about how to build the best, absolute best bang per buck 4K editing build PC. It's just a video of me building my particular 4K rig based on my requirements and my particular reasoning at the time of actually buying and building this PC. Now, the first thing to be aware of is I did not spend weeks or months planning this PC build. I did not, thoroughly research every CPU on the market, every architecture, every memory subsystem, every storage subsystem, every little nuance in terms of, like building the absolute best, most optimized rig. This was actually a sort of a last, really a last minute build. My previous dual Xeon machine actually was starting to play up immensely, and tax time is practically due. I needed a new PC and I wanted it that day. So literally I did my research at night, and then in the morning I ordered all the parts. An hour or two later, I went to pick up the parts from my local supplier, and then a couple of hours after that, boom, I was back in action. I had a 4K editing PC. That worked a treat. So, yes, sorry, this is not so. If you're after a video that's hugely, heavily researched and is going to give you the absolute best and most thorough opinion of PC things, you may as well stop now. This is definitely not it. Now, as I said before, my goal with this machine was not to get the absolute best bang per buck PC. I would have ended up with something entirely different if that's the case. My goal with this is that I actually had a budget for the machine that I wanted to spend, and in that particular case, I ended up with a budget for just the CPU. I had a rough budget. I don't really want to spend more than that. So my goal was pretty much, what's the best, overall general sense, what is the best processor I can get for that particular amount of money? And that's where my decision was coming from. So that's my thinking that actually led to the CPU choice, which was probably the most controversial thing out of the whole lot. Now, there were basically 3 other ones people were talking about. Basically, no one was telling me to go to a high, not many people anyway, were telling me to go to a much higher end system. Basically, everyone was using the bang per buck argument that I could have got a similar or slightly less performance for less money. But as I said, that wasn't my goal. But hey, it's actually true. I probably wouldn't have chosen the Intel 7820X if I wanted the absolute best bang per buck. So let's have a look at the basically the reasoning behind this. Basically, if we go into Passmark software, I know there's lots of people who don't think anything of this Passmark thing, but it's a good place to start. And if we search for the 7820X, let's go in here. I'm searching the high-end CPUs. So, the first port of call was to go in here and say, right, what is the, first pass, no pun intended, what is kind of like the best value CPU out of all these? Look, these are all many thousands. They're in the thousands of dollars range. These are all US dollars. I know street price is probably going to vary. Oh, there's the Ryzen Threadripper, the 1950X. That's $750 US dollars. I think that's well over I think it's like $1,300 here or something like that. I don't know. But it's quite expensive. It was out of my budget, so I didn't consider the high-end Threadripper there. The Intel Core i9s, they were all outside of the allocated budget for the CPU. I didn't want to go over that. I thought they weren't very good value for money, the i9s. So you basically go down the list here, and the first one you get to is, for $467 US dollars, is the Intel Core i7-7820X. And, you know, you read some reviews on it, and it's by all means a pretty decent CPU. If not the best bang per buck, it's still pretty darn good. So the reviews were pretty decent, and I had no problems. Right, so that was like the first cab off the rank. But then if you go down to search for the 8700K, which was under consideration, and it is significantly cheaper at, ballpark of $350 US dollars, but it's significantly slower in terms of pass mark there, but we'll look at the data further on. And the other one, of course, which everyone's talking about, why didn't I get a 2700X, the new Ryzen? It's just come out in a couple of months, so I didn't know a huge amount about it, but I did have a look at it, and, it wasn't quite as fast. It's not too far behind in terms of pass mark. It's not too far behind the 7820X, and it is significantly cheaper. So it's probably bang per buck. You could argue that, yes, they would be better, the 2700X or the 8700X from Intel would be a better bang per buck CPU. But as I said, I wasn't going after that. Now, let's actually take a look at some benchmark performances, because this is interesting, okay? Let's go into, this is the Antec website, and they've tested all these, CPUs, and they have like standard tests, and they compare them. Let's actually have a look. Let's go into like CPU encoding tests and things like that. So these are more sort of like real world results, and the results are going to vary greatly depending on whether it's single thread, multi-thread, all that sort of stuff. So here we go for 7-zip compression. The 7820X leads by a huge amount there over the 8700K and the 2700X. I really didn't consider really any other processors. So decompression, the 2700X actually wins, and the 8700K is down here somewhere, so it's actually better in decompression. Go figure. There's all lots of intricacies that go into the CPU architecture, the memory architecture, and all sorts of like huge, it's a science in itself, all this sort of stuff. WinRAR performance, let's have a look at that. The 7820X wins there. And yes, it is a nominally 140 watts thermal, so it is, the 7820X also would not win the award probably, although I haven't investigated, probably not win the award for the best performance per watt. So if that's important to you, you probably wouldn't buy the 7820X like I did. And then followed by the 8700s, basically on par. So, it's pretty decent. AES encryption, the Ryzen wins there. Let's go back to handbrake compression, which is a thing after my own heart. I don't do much handbraking now, but handbrake is something that I do actually, well, no, technically I do use handbrake to generate, I still use handbrake to generate my podcast, but I do some transcoding, and I, pretty much always, not using as much as I did, but I still use handbrake, so this is an important thing for me. Here we go, on low quality video, the 8700K actually just beats out the 7820X, and then the Ryzen comes in third there. But when you go to high quality one, the 7820X beats the Ryzen and the 8700. Where does that go? Yeah, the 87, yeah, it basically beats that quite handily, actually. So the 7820X wins there. And on 4K handbrake encoding, once again, the i7-7820 wins. They're not by a huge amount over the 8700K, but so general, and then we could go into other tests, and look, I'll link in the website. Suffice it to say that, what is it, rendering tests, we could like go to, anyway, there's rendering tests in here. The 7820X does this photorealistic render better than the Ryzen, and then significantly better than the 8700K, and there's a whole bunch of other tests. Suffice it to say, I've waffled on enough, that pretty much you could argue that the 7820X probably has the edge, but there's not a huge amount in it. Some things may actually be better. But let's take a look at the Ryzen 7 actually. It's actually only got 16 PCI, well, it's got 20 PCI Express lanes, and that can be important. It's only got 1x16, so that's dedicated all to your graphics card, and then it does have some others. So not a lot of leeway there if you want to actually expand your system in terms of PCI Express lanes, because if you use as you would, and as I am, you are using a times 16, you're using 16 lanes just for your graphics card. So that doesn't leave much left over. Let's look at the 8700K. It's only got 16 PCI Express lanes. So once you put your graphics card in there, boom, it's got no PCI lanes left over for the, to do anything else. So it's going to be potentially slower in a system. But once again, ebbs and flows depending. And the 7820X, it's actually got 28 PCI Express lanes. This isn't as many as like the much higher end ones, but hey, right, there it is. It's more PCI Express lanes, so it has more expandable capabilities. So, from this sort of thing, I gathered that the 7820, keep getting that wrong, the 7820 is actually not a bad choice. It's just more expensive. But, as I said, it was not only within my budget, but it was also on special, and I'm a sucker for a special. It was on special at my local dealer. They had it in stock. The other ones weren't on special. It was probably the gruntiest out of the processors, so I simply went with that. And that's the story behind choosing the 7820. So I don't think it's as bad a choice as people made out. It's just more expensive. As I said, you wouldn't buy it if you're going for absolute bang per buck. I haven't done the full research, but I certainly would not argue with anyone who says that the new Ryzen 2700X is probably the winner in the bang per buck stakes. So yeah, you'll get no argument from me. But anyway, I just wanted you to know the story behind choosing that particular processor. So once I'd chosen the 7820X processor, then of course it's the socket 2066, LGA 2066 socket. Therefore, I looked at my local supplier that I was buying all this from. I didn't want to go to different suppliers. I wanted it then and there that morning. They had all these motherboards. It's the X299 chipset. So if you're wondering why I bought that, it's because that's the chipset for the particular processor. So you have to go with that. So I bought, once again, I think it was on that MSI motherboard was on special. So for those who want to know the story there, yeah, it was on special. Had everything I wanted. It was a reasonably low price. Supported my 2066 CPU. They had it in stock. They didn't have most of them in stock. And Bob's your uncle. That's why I chose the motherboard. As for the other elements in the system, the CPU cooler, a lot of people said, oh, that's a crap cooler, it's not going to do the job. Well, sorry to tell you, it actually does do the job. Further on in this video, I've added some screenshots of some CPU temperature tests that I've done, not only when I'm rendering, but also absolutely running the processor flat chat. And if memory serves me correctly, during rendering, it's under 60 degrees. Celsius and a CPU temp, and under absolute full load, flogging all the cores, 100%, it's 70 degrees or under. So it does the job quite okay. There's, no reason to get anything else. I liked the low noise fan in it. Yeah, probably could have got lower noise, but anyway, it's a reasonable cooler, and it does the job. For those who are saying it doesn't, sorry, data shows it does just fine. And as for the RAM, I don't think few, if any, people really had much to say about that, apart from the wanky RGB LEDs. And yes, I It's just what they came with. It's the ones they had in stock that were a particular speed grade that I wanted, and I wanted them, you know, the set of 4x8 because it's a 4-channel memory configuration, and it's just what they had in stock at a reasonable price. So I got the RGB wankery. Nothing doing there. What else did I get? The solid state drive. Yeah, no one complained about the solid state drive, so it's one of the fastest and best on the market, so no problems there whatsoever. And the power supply. A lot of people said it's a piece of shit power supply, and I ruined my system by having this power supply. Well, okay, sorry. Guilty as charged. I just, at the last minute, I went, oh, I don't want to reuse the other one that I had because I had another use for the one in the existing case. I just want a power supply to get there in the system up and running. Once again, what they had in stock, one that had a noise profile that told me exactly what the noise was. I didn't bother looking at any reviews. I did no research. I deliberately bought, guilty as charged, a cheap Chinese power supply. But I'll include right now a teardown of that, a little impromptu teardown here. It's probably okay-ish. So yeah, guilty as charged. In a couple of years' time, if it fails, you can say I told you so. If not, well, I guess nobody's going to comment, are they? So yeah, I certainly wouldn't necessarily recommend that power supply. It works. It was cheap. The fan's really low noise. No. Okay, please don't take my stuff in here as recommendations to go out and buy stuff. Do your own research. And a couple of other things that a lot of people commented on. The fan, yes, it is actually installed properly now. I just didn't realize that at the time, but I quickly found out that it was in backwards. So that's all fixed. Don't worry about that. The XMP mode for the memory. Yes, I realized that as well because I hadn't actually tweaked that, and that's been tweaked, and I've actually shown at the end comparison the benchmarks with that on and off. I think there was like 6 seconds render time difference if memory serves me correctly, and also the overclocking as well. I have got the overclocking genie on. I switched that on so all the figures actually include that overclocking genie on. I probably could, you know, tweak the things a bit more in terms of overclocking and stuff like that, but I haven't done that yet. So there you go. I know this was long and waffly, but I wanted to add all this explanation that hopefully helps explain the reasoning behind my decisions. And you certainly, I don't expect people, don't expect everyone to agree with you. That's just impossible. Your goals are different to mine. I had a certain budget. I wasn't going for the best bang per buck. As I said, if you want the best bang per buck system, I'd probably say the Ryzen might take it out, or the maybe even the 8700. You can make an argument there if you don't need many PCI lanes. You know, anyway, I just got a pretty decent CPU for the price. Got it on special, and it was in stock. So there you go. So please, if you're going to comment on this video, please take into consideration my particular choices and why I actually made them, and thoroughly realize that yours may not be the same. So if you're gonna, you know, by all means, let's have a discussion in the comments. And, you know, so please, if you are going to argue about which one's better than what, at least, you know, define the terms that you're talking about. Yeah, best bang per buck, do this. That wasn't my goal. So, like, why tell me I could have saved money? That wasn't my goal. You know, so anyway, I hope we can have a productive discussion in the comments down below. And, yeah, hopefully I don't get flooded with emails and messages and comments asking why I did certain things, because I've just explained it. There you go. I don't expect anyone or even the majority to agree with me, but they were the decisions I went through making this. I hope you found it useful commentary. As always, discuss down below, and rest of the video follows. As I said, there's a couple of new things in there, but not much, basically. Yeah, catch you next time. Alright, so let's take a quick look inside this SilverStone 650 watt 80 plus bronze essential power supply. This is one of the cheapest power supplies that was in stock at the local supplier. And please excuse the crudity of this video. I'm shooting on my little RX 100 Mark IV, still in 4K by the way, but the light's not going to be fantastic. But anyway, quick look inside here. It actually looks quite neat and tidy. The first surprise here is that everyone said that this was, a lot of people said that this would be a piece of shit. Well, Nichicon main DC filter cap in there, high voltage DC filter cap. It doesn't get much better than Nichicon, a top quality brand cap. I'm quite surprised to find that in there. Now, in terms of the secondary caps, sorry, but it's actually hard to make them out. I've tried to have a squiz in there, but I can't quite make out the brand. I don't think they're, top quality Japanese caps in the secondary supply there, and I don't know if they're adequately rated. I don't know about the ripple and noise performance of this supply. I don't know about, its transient response or any of that sort of jazz. I've got no idea, apart from the fact that, well, it's probably, as good as you can expect from a bottom of the range, made in China power supply. So there you go. It's not too shabby. Ask me again in like a year's time whether or not this thing is any, is still any good or not. I just don't know. And I basically bought this, sight and research unseen. I just needed a power supply. It is very quiet. I got it because of its, it specified its fan noise profile and stuff like that, which I liked. It's probably okay, but I don't know. All you PC power supply aficionados are just going to absolutely laugh at this thing. But, you can say I told you so in 2 or 3 years' time. We'll see. Anyway, I'm building myself a new video editing rig, mainly because my current dual Xeon one, which I'll link in some videos down below, but I guess now they're out of date. And that's been a great rig. I've been using that for several years now. Dual Xeon processor. I did an upgrade to that, and it's generally it's been a beast of a machine, and it's done my video editing fine. But the problem is that the Supermicro server motherboard, dual Xeon server motherboard used in that is not compatible with Windows 10, and Windows 10 has caused me endless grief. And no, I'm not going to switch operating systems. No, I'm not going to go back to Windows 7 or whatever. Just don't comment on it, okay? I want a new machine which is fully compatible with Windows 10. So that's my main goal here with this new video editing rig. Not necessarily get some super blindingly fast video editing rig, but just to get A, better than what I've got now, and B, completely compatible with Windows 10. Get away from that specific server type dual Xeon architecture, and back, in this case, to the Intel Core i7 7820X LGA 2066 socket for those playing along at home, and I'm mostly going to be doing GPU rendering anyway. So the actual processor, there's no benefit to be gained by having a Threadripper. So I went with the i7 7820X. It was good value, it was available, and it's great bang per buck. It's not leading edge because ultimately when you go for a leading edge rig, your bang per buck just goes down. There's a curve where you reach that maximum bang per buck and then you just tail off. You get diminishing returns after that. So it's just not worth shooting for that. So basically what I've bought here is, some decent stuff, but it's by no means top end stuff, but it was in stock. It was affordable from my local supplier. So what I've got is the i7 7820X. I've got the MSI X299 chipset SLI Plus motherboard. There's many different variants on this, but this is the SLI Plus one. Once again, not the best performing motherboard out there by any stretch, but it had all the stuff I wanted, and it had suitable support for all the high-speed memory and stuff like that, which is probably going to be one of the most important things. Now that I'm doing 4K video rendering, that basically changes the game now, because I've got to, stuff like memory is really important now. Actually processing all that memory before it sends it to the GPU, and the bandwidth getting to the GPU and everything else, and the GPU actually being used. So, you know, it's more important to have fast memory or a fast architecture than it is to have the super fastest, absolute bleeding edge processor you can get. Anyway, so I've got the MSI motherboard. I've got a Hyper 212X cooler thing. Ones I want low noise. I do not want some stupidly high noise thing. So this is an extreme. I used this in my previous rig, or a variation of it. It's extremely low noise. It's virtually silent. I've got a 970 Evo M.2. This is one of the fastest solid-state drives on the market. It's only 256 gig. I've currently got a 256 gig drive. I'm only using half of it, so it's more than enough. And it's like, what is it, 3.2 gig transfer or something like read or write or something like that. It is one of the fastest drives. So that'll be my boot and Windows drive. I'll still be editing my videos from the RAID drive system, and yes, it's more than fast enough. You do not have to render video from a solid state drive. I won't go through the arguments again. Anyway, memory wise, I got this G.Skill. It's this RGB bullshit. Anyway, I got quad memory. It's 3 gig one. I could have gone faster because this motherboard does support up to 4 something gig. Could put faster, but it was prohibitively more expensive, so I went for this one, which was in stock and affordable, and it's the 3 gig version. So there you go. It should be fast enough. I got a new power supply. I don't know, SilverStone, I don't care. It had what I wanted, and it had a noise profile in it, very silent. Fantastic. That's what I want. As I said, I want low noise, because when I render in video, I might be rendering video for 20-30 minutes. If it's a real ridiculously long one, it might be an hour. It's not churning. I'm not playing games. I'm not doing this 24/7. So, you know, stuff like this cooler is more than enough. And something like this power supply, more than enough as well. And what else? I'm going to reuse my Fractal case that I got from the dumpster. I thought I was a bit wasteful. This is a reasonable ATX case, so I thought I'd reuse this Fractal case that I got. So I rip out the old motherboard in there. It's got an i7 960 or something. So I got a new power supply just to replace it. I'm going to whack it together. Going to put a new install of Windows on there, and we'll see how it goes. Now, the only real disadvantage with this Fractal design case is that on the top it doesn't have USB 3, so yeah, I don't know if I can some sort of, you know, get a board replacement for that, or, you know, I could just always whack them in the front or something like that. But I generally I have this way behind my desktop anyway. So anyway, it does have all the acoustic baffles on the panels and stuff like that. Up the top as well, which is all very nice, and I just like this case. It's actually quite decent. So, well, I know it's, you know, it's pretty old, and I got it from the dumpster, but I just going to reuse it. Why buy a new case when I think this one will do the business? So let's go. Let's rip the motherboard. Have to give it a bit of a clean first, but let's rip all the guts out. Start putting the new stuff in. All right, motherboard's out. Let's just whack the power supply in. There it is. For those playing along at home, caution, hazardous area. And comes with a lot of attachment thingamybobs. I really like this Fractal case. Even the power supply mount around here has a spongy anti-vibration mount on it. That's nice. So the fan from this doesn't transfer through to the chassis and then resonate the noise out. Really do prefer these ones with the plug-in Molex connectors. Just, you know, it's so much easier. Like, you don't, you know, you only have to use what you need, and you can probably get like different length ones and stuff like that. Just much nicer, but they didn't seem to have anything like that in stock, so we'll just go with this Octopussy. There you go, for all you Ziff socket fanboys. There's our MSI X299 SLI Plus motherboard, dual M.2 here. It's supposed to have, yep, metal, thermal design. You can screw those down. Apparently it dissipates heat probably through to the internal ground planes there. And, well, let's flip it. Oh, our socket's going to come off. And, yeah, no, there's no extra heatsinking on the bottom there for those. Anyway, there's our LGA 2066 socket. We've got 8 DDR4 memory slots, and as I said, I think it goes to like 4.5 gig or whatever it is, something like that. I've got 3 gig memory. We've got 4 PCI Express times 16 slots. Fantastic. The X299 chipset under here. It's got no shortage of SATA. I'm using like an external RAID, Ethernet RAID system these days, so a number of internal SATAs doesn't really matter. We've got some Turbo U2. Great band. Well, there's a couple of more SATA over there. It's got all the usual I/O. Apparently it's got like 11, at least 11, I think, USB 3 connectors, including a couple that go to the front panel. Is that those down there? I don't know. Anyway, figure it out. Might be able to whack some on the front, but let's have a look. It's got some audio wankery happening on up here. Not particularly concerned by that, because I use external audio. So we've got USB 3s. Oh, we've got some USB 2s there, do we? I thought I had all USB 3s. Anyway, USB 3.1, it's got dual Intel LAN on it. Oh, we've got a USB-C down there. Very nice. Good old PS2. You've got to have a PS2 for all, well, those gamer fanboys out there who reckon it's better because of the latency and all that sort of, you know, the interrupts and all that sort of jazz. Anyway, there you go. It's a motherboard. Apparently everyone's going to laugh at it because it's like not some super shit hot gaming thing. Came with an SLI H-Bridge M board, NVIDIA. Anyway, don't plan on using that. Whatever, CD, blah, 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 blah. Got our quick start guide, our memory, and a Pro Series manual. It's all in different languages. She'll be right. And they provide a couple of SATA cables too. Isn't that a nice touch? And the requisite backplate. There you go for you M.2 fanboys. Apparently it's a pretty schmick one, so I'm told anyway, but I'm sure all the experts out there will tell me otherwise. So installing this puppy, we have multiple locations here. We have to put it right through to the end. This one supports longer ones, and so this is only single-sided populated, by the way, so that's pretty impressive for the 256 gig. Anyway, so I had to move the screw, whack that in there. We're in like Flynn. This has a thermally conductive pad on the back by the looks of it. And this shield comes down over, and we should be able to screw that puppy in. That's the plan anyway. And that will be our solid state drive. Newfangled things. None of this SATA rubbish. And here's our DDR4 memory, the F4 3000, so 3 gig DDR4. Not as quick as you can get, but good enough for Australia. G.Skill with the finest in RGB wankery across the top. Heat sinking, all that sort of stuff. I love the DDR4 memory. You can see the subtle dip in there. It's probably like a millimeter total height there. This is to allow easier insertion force when you actually plug them in. So, you know, it just gently curves over like that. So these pins extend longer than these ones. Neat. And I've got a 4-channel capable processor, so we don't want that rubbish. So we want to use, I got 4 DIMMs, so I've got to install in B1, A1, C1 and D1. Cool. And in we go. Sweet. Not much force required on those at all. And there it is, the most expensive component in the system, the i7-7820X. So we should be able to overclock this thing if we really want to, but I don't plan on doing that straight away. Just want to get the puppy working. Ta-da! Let's put it in. Oh, looks like there's a pin 1 marker there, so I'd better match that up, betting I? Alright. In we go. That feels pretty good. Oh, got to take this out, don't we? That helps. Wiggle, 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 yeah. Yep, it's all good. Sweet, we're in like Flynn. Cooler Master fan time. Look at this desiccant. There's no crystals in there. Where are the crystals? I want my crystals. They got some stupid absorbent pad thing. What? Oh, no, there we go. There we go. Ooh. What's going on there? Some sort of gel in a packet. Inside a packet. Yeah. Oh, isn't that pretty? Look at that. All nicely set out. It's compatible with the 2066 socket and others, I believe. So, yeah, we probably don't need all that jazz, do we? Better read the manual. Here we go. What else do we need? AMD. No. Intel. There you go. 2066. That's the one we've got to follow. Better do that. That could ruin your day. Probably give that a wipe, because it'll have all the crappy glue residue on it. Get some isopropyl. Okay, we've got to make sure that these are actually set right out in the corners like this for the 2066. Otherwise they don't line up with the holes. But basically that then goes over, or goes in there, and goes over and forces your heatsink down onto your... And we've got our thermal compound, our little screws here. They even give you a nice little Phillips to socket adapter. Very nice. And yes, this isn't probably as good as your stupid whiz-bang diamond, whatchamacallit, wankery thermal paste, or your thermal seal pad or whatever. I don't give a toss. Tell someone who cares. It's good enough. They actually get their paste instructions halfway right this time. It doesn't show a big even layer right over the CPU like it did in their previous instructions. Yeah, we'll just put a little pea-sized dollop on top. I don't think we're going to use the whole tube. Yes, I'm sure there are those that will complain that I should be doing this after I've got it in the case, but I don't care. So, I've given it a wipe with my isopropyl. So, let's give her a squirt, shall we? Probably don't need any more than that. No wuckers. Oh, stringy. Alright, let's get this baby into position. It's in the centre. Well, it's got a little locky doodad thing there. Okay. Let's whack her in there. Give her a bit of a wiggle, yeah. And should be able to screw this puppy in. Do the opposite corner. I should have dirt. Trap for young players, that one. Take the fan off. Sure it tells you that in the instructions somewhere. And there we have it. One CPU. And attach the fan. Oh, look, it's got little extra ultra silent, like, you know, breaks up the vortex kind of thing. Anyway, supposed to be practically silent. So, awesome. And the fan's back on. Route the cable over to there. Over to our CPU fan, the system fan, pump fan. We don't have one of those ridiculous pumps. And beautiful. Like I bought one. In she goes. I think we got it. And we got heaps of length, or hopefully, on our CPU power. Yep. That looks hunky-dory. And this one has to go up the top, does it? Because I think it's up over there somewhere. We could take it here and snake it across, I guess. She'll be right. No wuckers. Now it's just the tediousness of all the other wires. We've got USB going to the top of the case. We've got USB going to the that card reader thing on the front. We've got audio. We've got the system, well, the front fan over here. Don't have the second fan installed up the top. Just don't need that sort of airflow. And then we got to do all the power switches and whatnot. I do believe that is now done. Sorry if this doesn't show up well. Just this all black stuff screws around with the exposure here. Look, if I put my hand in there, that should be super overexposed. There we go. But it's all done, all the wiring's done. I've still got all this extra, you know, all these extra SATA cables and whatnot hanging out of the thing. I'll tidy those up, bundle them together, whack them in the bottom, because you can't just... could snip them off if you wanted to. I don't need to install any other drives at the moment. I've got my M.2 drive in there for the boot drive. That's all I need to go. That's all I need to boot the thing up. All the wirings, all the cabling's in place. Fans are hooked up. Memory's all plugged in. I think we're ready to go. Oh, forgot the video card. Oh, I've got that at the office because I want to use the same one I've got in my dual Xeon machine. So I'll just whack in something temporary to get it up and running. That ought to do it. Might as well whack it. Is that the modern day equivalent to a Hercules graphics card? There we go. Spinning. Oh, we got RGB wankery. We got number. Oh, look at that. Oh, yeah. Oh, yes. The finest in RGB wankery. Look at that. 69, 36, E0. It's going through. Oh, and it shut off. No, it's starting again. It's probably figuring out what the RAM is. Anyway, the processor's working. If the processor wasn't working, then it wouldn't be doing all that jazz, that's for sure. So, I don't know, is it time to read the manual? There's nothing on the screen yet. No, we are actually getting something on the screen. Just didn't have it turned on properly. It said CPU memory changed or something, which is kind of what you'd expect, I guess. Come on. It's going to... Oh, Pro Series. There we go. Press delete. Whoop. Reboot. No, I guess it took all that time to... Yeah, it took like a minute. I guess it self-initialized or something. It's now showing 37, 38... 38 on the display. And that LED display up the top, that's the one I'm talking about. No, 39. Oh, that's temperature, is it? I think it's gone to temperature mode. Yeah, okay. Just toggle it back and forth. Like, look at that wankery. Look at that. Bloody ridiculous. When I was a boy. And we press delete, and we're in like Flynn. Check it out. It's all very monochrome, isn't it? Oh, I've got a splash of colour down here. All right, so... Our CPU base clock, 100 megahertz. CPU ratio 36, core voltage 0.988 volts, Intel Turbo Boost, blah, 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 blah. Where's our, there it is. No, yeah, i7, 7820X CPU, 3.6 gig. Now, the thing about this is that it's probably more important for the stuff I'm doing to have a higher peak CPU speed. So this will runs at a normal 3.6 gig, but it turbo boosts to like 4 gigs or something, is it? I don't know, something like that. Anyway, and that's without overclocking, so that's quite nice. So, memory. There we go, G.Skill, yep, it knows what it is. It's reading all the E2 Promi goodness. 15, 16, 16, 35, that sounds right. Profile, so yeah, it's automatically set that up. Current DRAM frequency, 2133. So the Samsung SSD Evo, there it is, it's reading that. No wuckers. That's our CD drive, no problems. Alright. There it is. M2 on the first slot, 250 gig, reads it. Fan info, oh look at that. Oh, we get a characteristic curve for our fan. Oh, suddenly got a bit moist. 574 RPM, fantastic. CPU 37 degrees. No, the oh well, it's probably A6 probably is the BIOS code for we're in the BIOS menu or something. Ordinarily it shows the CPU temperature there, and the system fan. 891 RPM. Speaking of which, I can barely hear this. I think most of the noise, yeah, the power supply down here is like, I don't even think it's, oh no, it's blowing slightly. It's got to be, it's got to be 500 RPM tops or something. Really slow. I think the fan in here, the system fan in this case, because it is quite old, I might replace that. I've got some Noctura fans, which I might whack in there. Once again, they're mailbag salvage, as is this, well, this case is a dumpster dive salvage, which is great. love reusing stuff, and look, it turned out to be a very nice case. It's got more than I need. Like, I could, set up, this motherboard does have virtual RAID on it. Doesn't have true hardware RAID, but you could set up multiple RAID drives in there if I wanted to. Yeah, I don't know. I've already got my external box that I'm really happy with, which is working great guns. Allows me to access all my stuff. I don't carry the SD card to the lab anymore. From the lab to the office anymore. I just upload everything via RAID. But the thing is, I've just started shooting in 4K, and now it's like 15 to 20 gig per, or more, I think 30 gig or something for a mailbag. That's a lot of footage. It does take an hour or something to upload, so, but I just leave it started. By the time I get to the office and dick around, it's, it's uploaded. None of that Cortana bullshit. No. Piss off, piss off, piss off, piss off, piss off. Hi! Hi, welcome to the EEVblog. There we go, we'll just leave that virtual rubbish enabled for now. 16 cores, 8 real ones. Alright, I won't bore you with all the details of the rendering test, but I'm using Vegas 15 here, which is my editing tool, and I've just basically done a 3-minute exact video here, just using my new 4K footage here. So if we go in, we can have a squiz at that. There it is, 3840 by 2160 at 30 frames per second. I've just added in, like, I've just got a fade in at the start and just added in my basic stuff like an image overlay and some text and stuff like that. So we're just going to render that and see what's what. I already have the results, of course, but I'll go in. I'm using the Magix AVC. I've got my NVIDIA GTX 1050 card in here, which has the Pascal chipset. No, the 1070 card is not supposed to speed this up at all, because it's not the number of CUDA cores that's actually doing the rendering here. The both the HD and the 4K rendering is done inside a didn't show you that, very specific hardware engine inside the Pascal chipset. So it's not the number of CUDA cores. So actually you can get away, so I'm led to believe, get away with a cheaper card on that. So anyway, I'm going to use the Magix AVC encoder, 4K. And let's have a look. So we're rendering at 4K. I'm going to do the maximum bitrate because I'm recording in 60 megabits per second. So why not actually export at a peak maximum bits per second of 60, but I'm going to have an average rate of 24, and I've done this on my old dual Xeon machine. I'm using the NVEnc encoder, which is the GPU encoder inside the NVIDIA chipset. Variable bitrate, audio 192. We're doing best video rendering quality, all that sort of jazz. So we can actually now run that. And by the way, all of my source material on here, these source files, they're all stored on my Synology RAID drive over my dual Ethernet connection. I've got like dual Ethernets to give a higher bandwidth, not that it matters. Because there's very little difference. There's only like a second or two difference that I've measured in terms of actually rendering to the RAID drive. Depends what the RAID drive's doing at the time. If it's, heavy use in something else or something, it might be like a couple of seconds slower or something like that. But no, I've tried it right into the M.2 drive, the solid state drive. It's it's not going to magically make it twice as quick. It doesn't work like that, because most of the time taken for the render is taken by the GPU doing its business, and also taken by the CPU, which then has to encode all this information, pass it raw to the GPU. And I have actually confirmed this. GNIF on the EEVblog forum, who's really into hacking NVIDIA cards, he's actually checked the source code for the NVEnc encoder that we're actually using here, and he has verified that it actually passes the full raw data over to the NVIDIA chipset. So that means, the CPU, you think, GPU rendering, it doesn't matter what CPU you got. Yeah, it matters. And as I said, the memory and the bandwidth between the memory, the CPU, and the video card, that all matters, because it's got to dump that 32 bits per pixel for that 3840 by 2160. It's got to do that for every single frame. So there's massive amounts of data that are actually being dumped here to the graphics card. Anyway, we can go in there and we can just go render, and it will be a bit slower here because I'm video capturing this screen, of course, but it basically ends up being, for a 3-minute clip, I've got it at clocking in at 2 minutes 56 seconds. So it's actually faster than real-time rendering 4K. And if you want to know what my previous dual Xeon machine did, well, it did the exact same test under exact same conditions, exact same video card in 3 minutes and 54 seconds. So it's practically a minute slower, my previous dual Xeon machine. So it's a very significant improvement here. And you can actually see the processor, but we're doing, as I said, we're doing video screen capture here as well, but it basically utilizes way over 50% of the processor when it's doing this, because as I said, it's got to decode all that, it's got to, decode all that data for each and every frame, and then dump all that massive amount of memory to the GPU. So, yeah, it actually, it takes some grunt, and the GPU, there we go, for those playing along at home. And there you go, the GPU for video encode, it's still, it's not maxing out on that. So it's so I haven't actually checked this GPU when I'm not capturing the memory, because it wasn't showing up before for some reason. Anyway, it's just, it jumps up to almost half there, 40%, something like that, but it's not doing it flat out at the moment. There you go, 2 minutes and 55 seconds. It basically, doing my screen capture, this is the first time I've done this, it didn't slow it down at all, doing the full HD screen capture as well as rendering. That's how good this new machine is. It's awesome. And then if you want to know about CPU encoding, well, we can do that by choosing the main concept AVC. Exactly the same conditions as before, and I've done this. And now it's, you should find that it's not using, there you go, the CPU is now flat chat, and it's a wonder I'm able to, the audio could drop out on the screen capture or something now. It could really crap itself. Anyway, GPU's doing basically bugger all now. It's all CPU. So there you go. But I can tell you that if we cancel that, I can tell you that it did the CPU encoding in 10 minutes and 37 seconds for that 3-minute clip there. And my old machine took 17 minutes 51 seconds. So it's actually 40%, the new machine is 40% quicker. I just on CPU rendering than my old beast of a dual Xeon machine, with the 24 cores or whatever. Yeah, I think I had 12 physical cores per CPU. 24 physical cores total, and it's this new one's 40% faster. There you go. That's what you get with the new faster CPU plus the increased memory speed. The DDR4 versus the DDR3, but from before probably plays a role. I have to break that down in individual testing. I couldn't be bothered. But anyway, new machine's 40% faster on CPU rendering. Nice.